Okay. Hey everyone. I'm Flo, I'm CTO at Coachit. I'm going to talk to you about how our thoughts about building a technical infrastructure that really supports innovation. So in every team, product, company, we're under constant pressure to change, be it from our competition, bringing in new products, bringing new features, by our customers that demand new features, that demand changes in our product, or even our team, process, and technology, which, let's be honest, completely change all the time, and we need to be able to deal with that change all the time. So especially in our infrastructure, that becomes very important, because our infrastructure determines how fast we can move, how fast we can innovate, how fast we can bring out new features, test our product, get our product to product market fit, and really get more customers in that sense. The problem there is that bad infrastructure really can make us fail. Bad infrastructure means we cannot move fast enough. We might not be able to move faster than our competition. We break our application all the time, which takes away focus from our team, from what they should actually be working on. Working on the product, finding what the customers really want to have, and building them in the future. And not fixing problems, fixing automated bugs that could be just automated away from the beginning of automated features in place. So with that, I want to give you 5 suggestions that help us and our customers in building an infrastructure that really works well with innovation that really supports you in that. The first one, the best part, the best optimization that you can do with your time is simply doing things, not doing things that somebody else can take care of. So using services, using external products where it's their product to really make it work, be it your log management or others. So you should not deal with that. Infrastructure is really hard to be able to manage and maintain. And unless it's your core value proposition, you really should not deal with infrastructure, unless it's really necessary. Because somebody else whose product is and who you can pay money for will make a much better job in doing that than you could potentially do yourself. It's something that really isn't core to what you should be doing. So I've written a couple of tools, I've written a blog post, released it today, that has a list of tools that we use all the time, that we really love, that I enjoy personally, and it really helps us a lot to get faster and to be productive. You want to take a picture? I'll leave that on for a second. Cool. So my second suggestion is build to replace. Too often when we start building an infrastructure, when we start building a code base, we build these huge monoliths that are really hard to maintain over the longer term. Once our team grows and the team grows that's working on the same code base, it really doesn't become manageable anymore. It's just monoliths that just don't scale with our team. We want to be able to move fast, bring out new innovation. And we want to be able that whenever there's something in our infrastructure that we need to replace with a new implementation, with something that's faster, we want to be able to do that. And that's just not possible if everything is one internal code base. So starting out and building smaller microservices and building on top of existing services is really something that can help us and helped us in the past and helps many of our customers to move faster, to replace each of them, deploy each of them separately, and thus manage a much larger infrastructure, and would be possible if all of that code base is in one place. And with today's services like Heroku, AWS, industry generally, the newly released AWS Lambda or container service, it's really possible to build infrastructure where all you care about and all you maintain is your code and your product, and you leave all the details of where exactly is it running, how exactly is it running, to somebody else, like AWS. Somebody whose product it is, who deals with that constantly, and not where it's not your problem, you shouldn't have to do it. So it's really possible to go for a very large part of the infrastructure. Something that we've certainly done a major mistake in the beginning is being way too frugal. I think a lot of startups especially run into that problem of, in the beginning, being way too frugal in how we want to spend money on services and external products. It's the time that I've personally spent on optimizing parts of our application to run on the same server, just so we spare a couple of bucks per month, is totally insane. It was a total waste of time. We should have set realistic spending goals and then actually spend the money to, again, focus on what is really the most important, building a part for our customers in the future. And so setting realistic goals and then really spending money on somebody else's products just so you can focus is, in my opinion, something that we've certainly been doing for a long time now and has helped us really to move faster. But once you have all of those microservices that work together and that get deployed oftentimes, you really want to make sure you have a consistent workflow and consistent way to get all of them out the door, to keep them up to date. And that's something that becomes really hard to do. And because you really, again, want to focus on the code. You don't want to get distracted by the workflows, like how exactly do we deploy this part of the infrastructure, or when you get somebody new and you really want to focus. And something that has helped us a lot with that is what we call repository-driven infrastructure. Basically, let me show you how it works in our team. We use GitHub Flow, which is based on GitHub as a workflow that's been described by GitHub. So whenever we want to launch a new feature, we open up a feature branch or a bug branch, or it's a fix for a bug. Then we keep working on that, keep iterating. And then at some point, you open up a pull request, ask your team for feedback. Once that feedback is in, you merge it back into a master branch, and then it gets deployed either to production, to staging, or somewhere where it's actually run. The advantage of that is that everything is deployed like that. For example, including our DNS, which makes it incredibly great for anyone. So we've recently onboarded our new VP of engineering, and one of his first questions was, okay, so how can I do changes to our DNS? Because that was necessary. All I need to do is point him to a repository, tell him there's a JSON file in there, he'll figure it out immediately how to do changes to the DNS, and do a branch, merge it back into master, ask somebody else for feedback. That was all there was to it. I didn't even need to describe him, use DNS simple, use this kind of tool, here's the login data. All of that was not necessary. I pointed him to the repository, and the same way I pointed him to other repositories to work on specific parts of the infrastructure. So it's the same workflow for anything that you work on in your infrastructure. It makes it really easy. And as I said, it's really trivial then in the end to switch between the different code bases. So what that leads to is an eventually consistent infrastructure. Eventually, your infrastructure will be consistent with what is on your repository. But that consistency, that transition, isn't really what you care about anymore. You just merge between the feature branch into your master, and then at some point it will be out in production. Or you'll get a notification that something didn't work. But again, keeping focus, and as soon as a feature is merged, as soon as a branch is merged, being able to go to the next feature, being able to work on the next thing, and not having to worry about any of the ways how to get it out the door, because that's something that just the system takes care of and it does for you, is really important. To keep focused, to keep working on the most important thing that you can build for your customers to innovate faster. But how exactly? What's some of the things that we or others use to build this kind of infrastructure, this kind of thing that you can exchange very easily all the time, you can move on quickly? Something that is key for us is immutable infrastructure. So my fourth suggestion is really to build immutable infrastructure. So what exactly is an immutable infrastructure? It's built out of immutable components, so servers that get replaced for every deployment. So anytime you want to release something new, you build a completely new image. That means that image can be a Docker container, can be an Amazon AMI, can be a virtual machine on top of VirtualBox or Vagrant or VMware or whatever you want to have there specifically, but it contains your operating system, it contains your configuration, your application data, everything in one image, everything in one box. And then it's really, really easy to take that and replace the existing servers, the existing part of your infrastructure. That's something that's really only been feasible over the last couple of years or more like that, where we have very easy virtualization and cloud services, of course, like AWS, Azure, Google Cloud, many others out there, that help us with that transition period. So once you've built this image, this one piece, this one artifact, gets fully tested and fully validated. And then you take that and clone it however many times you need it in your production infrastructure. Because you fully tested that one thing, you can be sure that it works on all of the pieces of your infrastructure. That's a very different workflow than it is for most infrastructure today, where you might have 1,000 servers and you deploy and update each one of them separately, and 5 of them fail. So you need to detect that 5 of them have failed and need to take them out of your production system, which is very hard, very complex. That's where very complex tools like Chef or Puppet exist. But what if you can remove that problem of updating or updates failing by just simply having that one fully tested system that you then roll out? So So let me show you an example how that works in our infrastructure and many others that do immutable infrastructure. So we have that new release, we test it and build and verify that it actually works. This can be like starting up a Docker container, making sure that any request against that works. In our case, we build an Amazon AMI, and then we run large integration tests that just take about half an hour just against that to make sure everything is in there, everything works. And once that is tested, we move it into our image store. So once it's in our image store, we know it works, it fulfills exactly our acceptance criteria, and we can use it to replace existing parts of our infrastructure. So let's say we have relatively typical system, load balancer, an application cluster, and a database. If you want to now deploy something new, we don't update that application cluster in place, we'll just start a new one with that new version. At some point, when that application is coming up, you can even test it now and just send requests against it just to make sure it's there. You'll atomically, in the load balancer, switch between the application clusters, which an atomic update, an atomic change, is a very different, again, workflow than in the past where you update each service or update service sequentially in your infrastructure. Because it's fully atomic, it's also easy to just roll back in case any problems happen and just go back to the old application cluster. And then, after a while, if everything works fine and there's no errors, we just destroy the old one, keep the new one, and we're at the new system. So that's a very different way to work that we found incredibly helpful for us. Specifically also because it's silo state. State really can only stay in your database. State being either data that flows in there or different configuration. I cannot log into an application cluster when I know it's going to be gone in maybe a minute, maybe 2 hours, maybe tomorrow. I have no control over that. So going in there and changing anything by hand or introducing any kind of state that is only in that specific piece of infrastructure will vanish. So you cannot do that by design. So state is really siloed where it should be. In the database here, for example, or only the changes that need to happen in one deployment in one part of the application. And also, deployment is the same as rollback. The same workflow applies. You'll just take an old image. When the new one doesn't work anymore, you will go through the same process just with the old image. Start up a new application cluster, atomically replace your load balancer in your queuing system or whatever specifically you use to connect your services. But that's as easy because it's the same workflow. Fully automated, and if any problems arise in your system, that can happen fully automatically without you having to do anything and maybe just getting a Slack notification. So what are the problems now with this small service infrastructure that gets very often deployed? It's really you need to have a proper way of good operations and good overview over all of your system. All the logs, all the data needs to be in one place. So the fifth suggestion that we've seen for us work very well and for others as well is unifying logging, monitoring, and alerting. You really want to have that one source of truth that contains all your logs, all your metrics, all the data about your system. Because chances are that if you run an infrastructure, replace it, and any kind of error happens, the system that triggered the problem is already out of production. It might already be gone, you don't have any access to it at all anymore. So you need that data somewhere else to be able to triage problems, to look into all the metrics and logs from all of your system combined, to make sure you can really follow through and triage and find the problem. So you need that one source of truth. In our experience, logs are an immensely underused piece of technology and system that can really be very helpful. Logs are super cheap, they're supported by any technology, anywhere. There are many services out there to make it really, really easy to collect all different kinds of logs together. We use Papertrail, we're really happy with that. They're a really good service. And then, once any kind of problem arises, to combine all of the logs from all systems together and look at them and check out if there's any kind of issues. But it's not just about having all that data. This one button. It's also about accessibility. You can have all the data in the world. If your team cannot properly access that data easily and quickly, especially when problems happen, you run into big problems because that data is totally worthless. A while ago, we've added a search and Papertrail link to different parts of our administration queues that whenever I click that, I'll get a open up Papertrail with a specific search related to that specific build. So if any of our customers tell us, okay, there was a problem, something happened or got stuck or something, I can check all the system logs for that specific build only without having to do anything more than just clicking a link. And that's something that isn't just necessarily helpful for the engineering team, but you could have, for example, your business team, your support team, checking out all the logs that are there for a specific user that asks for support, just so the data is as easily accessible as possible for them. And something that has helped us tremendously as well is chat-ups. We live in Slack. We are in different locations, different time zones, so chat is something that is very important for us. Whenever there's a problem, we want to make sure that we all have the same data and discuss the same data to really make sure there's no misunderstandings, no different points of view, because we look into different parts of the infrastructure. So pulling in data into a Slack chat, there's many different integrations out there to show like the logs that we want to all take a look at, and system status in there is incredibly helpful, just to discuss the right problems, the right data, and have the same kind of view on that. And in our experience, skipping here costs 100-fold, because it's not just about how quickly you can react to problems in your infrastructure, it's also oftentimes through your metrics, through your logs, you'll see problems early on that you then can fix before it impacts your customers at all. So it's really important to invest considerable time in the beginning, and all those services out there that can help you. It's actually not that much time needed to set all of that up, because there's so many things out there that take that away from you. You can check out the blog post I mentioned before for many of the services that we use for that. And also because you have all of that wealth of information, you can start automating your scaling and your healing even. So your system can heal itself whenever any kinds of problems arise. So for example, when we see too high ping in our infrastructure, we just remove that server at all. Not even having any kinds of impact to customers, but just we don't want to deal with that potential problem of network problems on AWS. Nobody wants to deal with that. So we just remove it, start another one, and deal with it that way. So to recap, the 5 suggestions that I have is using services to make sure you don't spend time on something that really isn't your core product value. Build to replace, so you have an infrastructure that is not that one big mess of a code base, and can be easily replaced when you need something faster in a different language. That repository strategy infrastructure, so you have the same kind of workflow throughout all of your code base with all of the infrastructure. Build it immutably, so exchanging any part becomes very easy. And then unify logging, monitoring, and alerting. So whenever anything happens in your infrastructure, you have all of that data in a separate system, can look at it, can find problems there. And all of those in support of one higher goal. And that is to focus on your code and on your product. Because all of the distractions that we see constantly with having to go fixing things, monitoring things, are a distraction of building something that is valuable for our customers. And we don't have enough time to lose focus. We really have to focus on making the best for our customers. Thank you. We have like around 2 minutes for QA, but you can also always send me an email, or I'll be in town till like Monday, so if anybody has a question as well, let me know by email anytime. Any questions?
So database infrastructure, how do you deal with that with the immutable state?
So 2 things. So one, we have a service. So we use Postgres, for example, that's really good, or Amazon. I think that specifically is hard to do immutably. But it also doesn't change a lot in terms of like how the system itself has to change, upgrades to the databases. Typically what we do is we let it be somebody else's problem, not really that constantly. But also often changes to schema or something like that doesn't have nearly as often as changes to your application code. So it's something that you let somebody else do. The other question?
But how do you handle schema changes?
We have, for example, a large Rails infrastructure, so we do Rails migrations, and we do that in place. So schema changes are done for us in place. We don't consider the database part typically immutable. I think it's technically possible to do it completely immutable, but just so much time spent on that, where the value of doing it is not really that big. And so buying it as a service, at least for us, was in the past a better solution. But it's theoretically, technically possible. Thank you.